In this video, I'll be going over a few examples of the cosecant and secant graphs. And what it says up here is to graph these functions, all we need to do is graph the corresponding reciprocal functions. And so for cosecant, that means we first graph sine, and then for secant, we graph cosine. All right, so our first equation says graph y equals 3 secant of x plus pi over 2. Find the period, amplitude, any horizontal and vertical shifts, the equation of the asymptote lines, and then the domain and range. Now, taking that initial equation, I'm going to write it into the standard form. And the standard form is much like what we've seen with the sine and cosine standard form. So I'm going to factor out a 1, x plus pi over 2 plus 0. And I do this so I can identify the a value, the b value, c, and d. All right, and so each of those tell us something about the original cosine graph. And so what I'm going to do is I'm going to think of this just like it's a cosine graph and graph that first. So the period length for cosine is, the amplitude is the absolute value of a. So this is the absolute value of 3, which is 3. Because a is positive, there's no vertical reflection. The period length, or the fundamental period, is 2 pi over b, so 2 pi over 1, which is just 2 pi. The horizontal shift corresponds to that c value. This is going to be left pi over 2 units. And remember, make sure we say left or right. And then there's no vertical shift because the d value is 0. So we say none here. All right, so I'm going to map out my period length. This is 0 to 2 pi. Half of that is pi. Oops. Half of pi is pi over 2. Or what I should say is between pi and 2 pi, all I do is I add these two together. Pi over 2 plus 2 pi over 2 is 3 pi over 2. And then to find or to apply the horizontal shift, I'm going to subtract pi over 2 from each of these values on the number line. And that'll give me my shifted period that we're going to look at. So this is negative pi over 2. Pi over 2 minus pi over 2 is 0. 2 pi over 2 minus pi over 2 is positive pi over 2. 3 pi over 2 minus pi over 2 is 2 pi over 2, which is just pi. And then 2 pi, to write that with a common denominator, 4 pi over 2 minus pi over 2 is 3 pi over 2. Okay, so I'm going to go ahead and map that out on this graph. I'm going to use 3 blocks here for each of these tick marks. So that's 0, pi over 2, 3 pi, it's pi, and then 3 pi over 2. Okay, make sure I have everything applied. I have an amplitude of 3. 1, 2, 3, and then down 3, so negative 3. There's no vertical shifts, so the horizontal axis isn't changing. And then remember, a cosine graph has its maximum values at the beginning and the end. The minimum value is going to be down here at negative 3 at pi over 2. And then we're going to hit at 0 and pi. So this is getting us to the point for the cosine graph. And what I'm going to do is I'm just going to draw a dotted line here, because this is just going to be a reference for the secant graph. Okay. And then from there, what I'm going to do is I'm going to draw in the vertical asymptotes. So the vertical asymptotes are where the cosine graph hits 0. So I have a vertical asymptote at pi, and then a vertical asymptote at 0. Okay. And then now that I have all of this put together, now I can come up with the graph for the secant function. And that is, I draw it off of the maximum values and the minimum values, and it approaches those asymptotes. So the blue graph is the secant graph. And what you could do is you could go through and erase the cosine graph if you're careful. So it's going to look something like that when it's all said and done. All right, and what information are we asked for? We found the amplitude, period. We found the shifts. Next, we want to find the equation of the asymptote lines and then the domain and range. Okay, so the equation for the asymptote lines, what we want to do is we want to come up with a general equation that will generate the infinite number of asymptote lines that we have. So remember, this graph just repeats this for every location on the number line. So we have an infinite number of asymptotes. And so the formula for the asymptotes is y is equal to any asymptote plus k times the distance between asymptotes. Now, this might not make sense, but once we do this example on the next one, hopefully it becomes more clear. All right, and I should say k is any integer. So any positive integer, any positive or negative whole number. All right, so I'm just going to use this formula to come up with the equation. And these are all y equals because vertical lines are always in the form y equals. So this will be y is equal to, pick any asymptote. Well, the asymptotes I see on the graph are 0 and pi. I could use either of those. So I'll do 0 plus k times the distance in between asymptotes. Well, the distance between these two asymptotes from 0 to pi is just pi. So my equation of the asymptotes, I don't even need to write that 0. I could write y is equal to k times pi. So what does this mean? Well, if I want to know where the asymptotes are on this graph, I just can pick any integer value for k. So if k is 1, I get y equals 1 times pi. So y equals pi, and that is this one. I could pick k equals 5. That would mean one of my asymptotes is at 5 pi, and similarly all the way down. So any integer for k will give us an asymptote line. Okay, and then lastly, we want to say what the domain and range is here. So the domain is a little bit different than the sine and cosine graphs because we have all these asymptotes. So there's a few different ways we could write this. Because there's an infinite number of asymptotes, we don't want to write this in interval notation because we would have to write an infinite number of intervals. But we could write this just in words. We could say all real numbers except, and the domain is everywhere except where those asymptotes are. Well, we already figured out how we can find the asymptotes. It's anytime we have k times pi. So all real numbers except k times pi for any k integer. So the domain is everything except where we have the asymptotes. That's what that is saying. And then the range here is also different than the sine and cosine graphs. What we see is that we go from negative infinity, so all the way down here, up to 3. And negative 3. And we're going to include negative 3. And then union from 3 to infinity. So 3 to infinity. And there is the range. All right, let's look at one more example here. This is now a cosecant graph, so I want to think of this as sine first. Writing this into standard form, I'm going to say 1 cosecant. I'm going to factor out this 4 to give me an x value there. And so what I need to do is I need to divide 4 pi over 3 divided by 4. 4 pi over 3 divided by 4. That's the same thing as 4 pi over 3 times the reciprocal of 4, 1/4. The 4's are going to cancel. We get pi over 4 there. So minus pi over 3 is what I should say. And again, if we want to make sure that that is correct, we can simply distribute that 4 through, and we see that we get what we started with up here. Okay. So then I just have this negative 3 at the end. All right, so I can identify the A, B, C, and D values, and that gives me a map to find all the information for the graph. So the amplitude is the absolute value of A, so it's just 1. The period length is 2 pi over B, so pi over 2. For the horizontal shift, we're going right pi over 3 units. And then for the vertical shift, we're going down 3. All right, so this finding this period is going to be a little bit more work because these fractions are not quite as simple as what we've seen. So I always start at the beginning and end. So 0 to pi over 2. Half of that is pi over 4. Half of pi over 4 is pi over 8. And then getting that third quarter, I add pi over 8 and pi over 4. That's the same thing. Pi over 4 is the same thing as 2 pi over 8. So getting a common denominator between those two, I get 3 pi over 8. Okay. Now I need to add pi over 3 to each of these. And let me just move that. So I'm going to add pi over 3 to each of these positions. And this is a little bit of work because none of these have a common denominator. So 0 plus pi over 2, well, that one's, 0 plus pi over 3, that's the easiest one. Okay, but I need to get a common denominator between these other fractions, and for a couple of these, they're going to be 24. So the common denominator between 8 and 3 is 24. So I'm going to have 3 pi in the numerator for that, and then 8 pi. So this position is 3 pi plus 8 pi is 11 pi over 24. Okay, continuing on, 24 and 24. 8 times 3 is 24, so 2 pi times 3 is 6 pi. 3 times 8 is 24, so pi times 8 is 8 pi. Adding those together, 8 plus 6 is 14 pi over 24. And I can reduce that to 7 pi over 12. And I'll do that. Okay, 3 pi over 8 plus pi over 3, well, that's 9 pi over 24. 3 times 8 is 24, so that's 8 pi. 9 plus 8 is 17 pi over 24. And then on this last one, the common denominator is 6. 2 times 3 is 6, so 2 pi. 3 times 2 is 6, so this one should be 3 pi up here. Then the bottom one is 2 pi. 3 pi plus 2 pi is 5 pi over 6. So that one is definitely a little more complicated, finding all of those values. But I can still map those onto the graph. And I'll just do 2 boxes for each quarter. So pi over 3, 11 pi over 24, 7 pi over 12. Let me zoom in here and do this. Okay, we have pi over 3. We had 11 pi over 24. We had 7 pi over 12. We had 17 pi over 24, and then 5 pi over 6. Okay, so there's those key values. We are graphing a cosecant graph, so we're going to start with sine. The amplitude is 1, and we're shifting down 3 units. So originally, I'd be going between 1 and -1, but I'm going to shift everything down 3 units. So from 1, subtract -3, I go down to -2. So that one goes to here. And then taking -1, subtracting 3. I'm going to be off the grid. Sorry about this. Let me start over. So I'm bouncing between 1 and -1, but I'm shifting everything down 3 units. So instead of being a maximum value of 1, I'm going to have a maximum value of -2. That's subtracting that by 3. And then -1 subtracting by 3, I go from -1 -2, -3, -4. So this one goes to here. Okay, and so my new horizontal midline is at -3. And let me clean this up a little. Okay, so the graph is going to be bouncing between -2 and -4, and it's kind of revolving around that line -3. And so for the cosine graph, the leading coefficient is positive, so I don't have any vertical reflection. So the cosine graph is going to hit here, the middle at 11 pi over 24, and then 7 pi over 12, and then back up like this. So the cosine graph, oops, goodness, this is a sine graph that I want to start at. All right, one more time here. So sine is going to hit at the beginning, middle, and end. Maximum value at the first quarter, minimum value at the third quarter. So there's the sine graph. Next, we want to drop in the asymptotes. The asymptotes are wherever the sine graph hits the horizontal axis. So in this case, it's the beginning, middle, and end. And then lastly, the graph is going to be going off of the minimums and the maximums towards the asymptotes. Okay, and there we have it. So I can, if you're careful, you could erase your sine graph, but that's okay. All right, so what we need to do is we need to come up with the equation of the asymptotes, just like we saw before on the previous example. It's y equals any asymptote plus k times the distance between asymptotes. Okay, so this will be y equals, I have an asymptote at pi over 3. Usually we pick the very first one that's in the positive, on the positive side of 0. So y equals pi over 3, and then plus k times, well, what is the distance between these asymptotes? So to find the distance between asymptotes, you just take those two asymptotes and we subtract them from each other. So 7 pi over 12 minus pi over 3, I get a common denominator. That's going to be over 12, so this will be 4 pi. 7 pi minus 4 pi is 3 pi over 12 that I can reduce to pi over 4. So this is pi over 4 is what gets multiplied by k. So there's the equation of the asymptote lines. The domain, again, is everything except that those asymptotes. So all real numbers except when x is pi over 3 plus k times pi over 4. So everywhere except where we have an asymptote. And then the range. Okay, so the smallest y value I have is -infinity, and that goes up to -4. So -infinity to -4 union. Then I start again at -2, and I go to positive infinity. So -2 to positive infinity. And there we have it.